equals 2 times 5 to the x. Now, the box that says type of problem, we're either going to write that it's an exponential or it's a logarithm. So would you say this is an exponential equation or a logarithmic equation? It's an exponential. All right, so right here, this is an exponential. Now, we don't know yet the method to solve, meaning if it's an exponential, the only two methods we can use are either to use a logarithm, to take the log of both sides, or to use common bases. We don't know yet, so we kind of have to start this problem until we can figure out for sure. So how would you start solving this then? Divide by 2. When you divide by 2, you get 8 equals 5 to the x. Now, can you use common bases there, or do you need to use a logarithm? Logarithm. So the method to solve here is going to be take the log. What kind of log? The common log or the natural log? The common log of both sides. Why am I using a logarithm? Anybody know? What's the inverse of an exponential? A logarithm. And we have to take the log to move the x out of the exponent. So let's throw a log at this problem. I'd have log of 8 equals, when I take the log of the right, what happens with the exponent? It comes in front, x times log of 5. I'm going to divide by log of 5. And can someone type log of 8 divided by log of 5 into your calculator? 1.292. Good. All right, so that's the first kind of problem where you have an exponential and you have to use a log to solve. The second one here, what kind of problem is that? An exponential or a logarithm? That's also an exponential because there's an x in the exponent. Now again, I can't tell what method I'm going to use until I start a little bit here. So what would be your first step to solve? Add 3. So I add 3 and I get 27 equals 1 over 9 to the x. Now from there I can tell what method should I use to solve here? Common bases. Could I use an exponential to, or I'm sorry, could I use a logarithm to solve this if I wanted? Yes, but common bases might be faster. What's the common base here? 3. So I'll have 3 to what power for 27? 3 to the third equals, what's this for 1 over 9? 3 to the negative 2. So I'll take 3 equals negative 2x and divide by negative 2. So I get negative 3 over 2 is x. And also just a reminder that when you use common bases, you will always get a rational answer. Okay? So that's the second kind. So you have 2 exponentials here. You have to maybe start a little bit before you can decide if you need to take the log or use common bases. Flip on it over. A couple more, and then I'm done. E to the 0.56x equals 100. What type of problem is that? Logarithm or exponential? Is there a log there? No, it's still an exponential. There's still x in the exponent. So this is still exponential. Can I use the common bases when I have e? Probably not. So instead of using, I can't even use common bases here. So the method I'm going to use is use a logarithm. What kind of logarithm am I going to use here? Natural log. So you're going to take the natural log of both sides. Okay, so I take the natural log of both sides and I apply my logarithm law. Because remember, the natural log is the inverse of an exponential base e. So when I take the natural log, I get 0.56x in front of that natural log of e equals the natural log of 100. What happens to the natural log of e? It goes away. It's just 1. So maybe we can make it invisible. And what's my last step? Divide by 0.56. So can someone calculate what's the natural log of 100 divided by 0.56? Yep, 8.224. Good? So those were our 3 types of exponentials. right? We have an exponential that we have to use the common log for because there's no e. We had exponentials that we could use common bases for, and we had an exponential I had to use the natural log for. Last one here, last two. What type of problem is this, a logarithm or an exponential? It's a logarithm because there's a log in it. Now, in order to solve a logarithm, I have to use its inverse. What's the inverse of a logarithm? Exponential. So I need to turn this into an exponential. Right? The inverse of a log is an exponential. So I'm going to use the definition of a log to turn that into an exponential equation. What's the base of this common log? 10. So how do I turn that into an exponential to solve it? Remember, use your curly Q idea here. It's 10 to the second equals 4x minus 8. Okay, what's 10 to the second? 100 equals 4x minus 8. And if I add 8, I get 108 equals 4x. Which I get when I divide. 27. All right, and lastly, do I have an exponential or a logarithm here? Logarithm. So this is also a logarithm. What do I have to use to undo that, solve the logarithm? Turn it into an exponential. Now, what's going to be the base of this exponential in particular? E. So turn this into an exponential with base E. The one above, I know we used base 10, but it could have been any base that wasn't E there, or wasn't 10. It could have been 2 or 7. So here, what's the exponential I turn this into? E to the 0 equals 6x. Oh, that's 6, not 60. What is e to the 0? 1. So you're going to have 1 equals 6x. And what does x equal? 1 6. Okay, does that help kind of organize it for you a little bit? All right, so what you're going to do is you can do anything on the review that you want now. And we're doing review for a little while today. But the next, I don't know, 12, 15, 20, I don't know, a lot of problems there. A through O, that's a lot. Are mixed up of all these 5 kind of methods. So look through, see if you can use one method. Use your chart to help me. Skip around if that gets boring for you.